This is issue number 78 for the Kaiju Engine. It's been a little while. I had about a week off where nobody in my family was sick, but my son got sick, then I got sick, then my wife got sick, then my son got mildly sick again, then my daughter got sick, then we had a week break, then my daughter got sick, and now my son is sick with another fever. So it's been crazy, but show must go on. So we left off doing the UI stuff last time. And what I want to do this time is set up the UI panel. And this is going to be the base UI element. There's two base UI elements. There's the panel and the label. And pretty much all other UI elements are composed of these two, or it has a composition of all of them. Many panels, for example, can make up a UI. A button is a panel with a label inside of it, that sort of stuff. An input box is a panel with a label inside of it that when you type, the letters come out. So pretty much those two are going to be our base. So we're going to start on the panel. And the panel is going to include scrolling and that sort of stuff. So before we get to the panel, though, there is some cleanup that I noticed I want to do. So we'll jump on that first because it'll be easy. So the first one is instead of the host, I want to go to where I do render. Oops. Oh, it's right here. So just after I swap the buffers, I'm probably going to do this on a thread this, where we're going to go through all the entities and tell their transforms to clean. So for E, and we might do this as soon as we, on demand, actually, at some point. Entities. E dot transform dot reset dirty. We may do this on demand, but currently we have some code that relies on determining if the transform is dirty. So we may make it so that when it's requested, when the matrix is requested and it's dirty, it fixes the matrix, turns off dirty, but then has some sort of flag saying I was dirty this frame, and then we would use that boolean to determine if we should update to its matrix and all that sort of stuff. So yeah. So we'll also say thread this or make the dirty on demand and have a flag for the dirty frame, something like that. Okay. Next, there's a couple of things I want to add to color. Just some helper stuff for a little bit later. Our transparent I have is 0000. Let's do 1110 just because that is a little more obvious that it's not accidentally just a empty, just a zeroed out array of floats. And then we'll have a separate one for func color 0, which is going to be all zeros. Then I have a couple extra helper functions for equals, so func LHS color equals RHS color bool return. We're going to cast them to a vec4 LHS dot equals vec4 right hand side, so we'll just reuse that vec4 stuff. And then func c color is 0 bool return c dot equals color 0. Yep. Cool. So that's why I want to add what I wanted to add in there. So next, I want to go over to our config inside of matrix, and notice we have this clamp here, and we're checking for a float. We can get rid of the generic nature of this and just use float. Makes sense for what we have set up at least, and that will make it globally accessible so we can use that without having to do the max min trick every time. That means that we need to go to where it was used, change that to a capital. And next, I want to go into the transform on the same kind of note of the dirtiness. When we go to get the matrix, when we request the matrix here, We need to say if t dot is dirty, we need to t dot update matrix. Update matrix. Now this may be called multiple times, so this is where that whole marking it not dirty would come in, say right here, and then setting the flag for this frame that it's dirty. And rather than setting a Boolean that has to be updated on every transform all the time, we could have the host or the window itself keep track of the frame count in a big integer and just do a comparison on that. Of course, after decades of the program running, you may have a scenario where you loop around and update the transform accidentally a second time when it hasn't become dirty. But that's something we won't have to worry about. Anyways, that's going to be a separate thing that we're going to do to optimize this a little bit. The other thing that we want to do is when we set up the drawing stuff, so draw instance, we have a transform in here, but we have no way of setting it outside. And we're not really going to set it outside of this package. But just in case we need to do some other operations when we set it, we're going to create a function here. Set transform, and then we're going to assign it here, func set transform. I'm pretty sure it knows what to do at this point. And let's put it down here with the set model code. Okay, and then just to make it so that we don't have to set this model manually every single time using set model identity matrix, we'll make a little simplification helper func new shader data base. Yeah, that's exactly what I want to do. Model identity and return that. Now we have a destroy, and so we have a destroy. No, cancel. We have a destroy. We also want to be able to cancel our destroy, just in case something tries to destroy it, and then we don't need it destroyed because something else resurrects it or whatever, and so we don't have to go through the whole garbage collection. We can save it in the same frame, sort of thing. Cool. So let's use this set transform inside of our drawing. Whenever we are here, we say drawing dot shader data set transform drawing transform. So we just bind it in there when we pass along that structure. And now another problem I saw was instead of the texture.go, when we're running, we create our texture. We have a pending data here, but we don't set the width and height of the texture, which we're probably going to need. So we're going to assign those there. Okay. There's a lot of little things here that were bothering me. So we're going to go to shader data. I'm going to change foreground color and background color. Instead of vector 4, we can use color here because those are also a vec4. There's also a 4 float array. Just makes it more straightforward when we assign and use it. And then our last one is inside of layout. We're going to go to our initialize. And what I want to do is pass in the anchor here. So, and the UI anchor. And then we can just assign those. So the layout anchor is there. We say layout.ui is equal to UI, and layout.anchor to anchor. There we go. Clean that up. Okay, now I have prepared the panel code because I'm porting it from the Go game engine that I previously wrote, but I've changed quite a few fundamental ways of doing things in this version of the game engine, so I had to port it and rewrite a bunch of stuff. So that being said, there's a few things I need to fix inside of the base UI itself. I need to add a clean function that is publicly accessible, a set group function, so we can set the group externally as well. And then I want to have a set or self scissor here as well, so we can get the current scissor abstractly from the interface. And then we're going to get rid of this clean because now we have the public clean function. Another thing is the scissor is part of the shader data that we are working with. So we don't need to actually have the scissor anymore directly inside of here. And that means we're going to change this to UI.shader data.scissor. And we're going to change that everywhere else we have that, which is probably all these, some of these other errors. Let's capitalize that. We'll come back to that because it's not implementing it. We don't need to set scissor equals scissor. We need to set shader data scissor to scissor. And that'll get fixed. And then this one. Okay. So now let's find our clean function. Change this to a capital clean. Oh, it won't let me because I have errors. Capital clean, which will make this one error. And then we set up another function here for self scissor that we need to write. So let's go down to where all our stuff is. Here we have has scissor. We're going to use self scissor matrix dot vec4 return shader data scissor. I guess we don't need this helper function, but because we have access to the shader data through its getter function here, but that's fine. And now we need a set group, UI base set group, and that fixes all those errors because now I've implemented the interface. So let's go to the init function. And let's see, we have our host, we have our texture size, and we're going to need to know our anchor, our self UI. And that's because we were doing add name data UI, which is going to be the UI base pointer. And I think we're going to have some issues with doing the cast out of this UI base to another type. So we're just going to pass in self to the add name data there to resolve any potential problem that may have. And when we create the shader data, well, we don't really create it, it's just a member. We need to do shader data.setModel. And this is a case where we can't use the other function because this is already set up. I guess we could do like shader database is equal to rendering.new shader database. Sounds like database. I don't know. I might rename that later. But really, all we need to do here is that part of rendering? No, is it? Oh yeah, it is. I guess so. We just need to set the model, but that'll do it for us. And if we decide to do any other initialization, we'll have that there as well. We need to do UI layout.initialize, pass in our UI and our anchor. And then after we've added our name data, we can also do UI.shader Shader data.scissor is equal to negative max, positive max, positive max. Cool. I'm actually going to move that up here. And I think that's it for our initialize. Okay, so now our UI is all set up and ready for our panel. We are going to put our panel together. And I'm going to do this similar to what I was doing before, where I'll bring over chunks and kind of explain it. Explain the panel because, like I said, I've already written this in another engine and I'm porting it over. So let's get started. We're going to start off with a couple of constants. We have our scroll direction. We have none, vertical, horizontal, and both. Those are our options. And then we have our border style. These are going to be related to CSS. We're not going to implement all these right now. We will implement them over time, but these are our options for our different borders. Oops. Okay. All right, for the man of the hour, we have our panel. Don't worry about this right now. It's just an embedded structure here. So we have our panel, which is derives from that UI base or composes that UI base. We have a few vector 2s for our scroll or offset and our max scroll. This is for scrolling the window around. How fast the standard scroll is, the direction of the scroll, the event itself for when we scroll, the child events. So these are all of the child elements inside of the panel. So let's say we have a panel, and then we have a panel inside of that panel. Um, we want to make it so that we can click and drag to move the panel up and down. That's useful for mobile, and we can disable that later for desktop, or use the scroll wheel to scroll in that panel. And I should be able to hover my mouse over a child panel and scroll, and the parent will scroll, unless the child panel has a scroll and it scrolls a child. So it's pretty complicated the way that you compound these possibilities. But this just allows us to turn off events on the child if we're currently scrolling the parent. So let's say that this block of text here was a child panel and you could scroll inside of it. If I clicked outside of the panel over here and moved up and down, and I moved my cursor over here, my finger over here on a touchscreen, um, the scroll events for this area should have been disabled because I'm scrolling on the parent, and then I just so happen to move my cursor over this. So that's what all that's about. We have the color for this panel, which this actually we may wind up stripping because we have access to the foreground and background colors. This is going to be the drawing that we set up for this panel. Local data, this is going to be useful if we want to create various different kinds of panels by wrapping this panel. You know, if we did like type button is a panel type kind of thing. We then can associate local data to the button, and we don't have to create a new structure and then compose panel inside of it if we don't want to do all that madness and we still want to operate it as a panel. We have the update ID. This is for the update function. Some booleans to know whether we're scrolling, whether we're dragging this panel. If the panel is frozen, like we're not allowed to drag it or scroll it or anything. Determining is a button. We're probably not going to need this. I'm going to leave it for now just because it was part of my copy over. So I may wind up removing this. And fit content is just when we have panels inside of if we have child elements inside of this panel, if this panel should scale up to contain the children. So that's what all those fields are. Okay, so you should understand how a panel works just from that structure. Now we get into the details. Whenever we create a new panel, we give it the host, the anchor, and the texture we want to use for the background of this panel. We set up this panel with its defaults. Fact content right now is going to be true. Then we are going to init the panel, passing in the texture size, the host, the anchor, the panel. Set up the scaling to just be a default scale. Clean the panel so it regenerates everything. We're going to set up the scroll event. This is going to be a function that generates the background image if it's not already there. Because we can remove the background from panels at any time and then add them back in, so we can kind of change out how they look on the fly if we want to. Then this is going to be our update ID, so because we need to update UI every frame to determine its click and scroll and all the other stuff. Okay, now we're getting into some fitting stuff where you have a helper function for turning off fitting. We can determine if we are currently fitting, and then we can also tell it to fit the content. Set dirty type generated. Probably going to need a fit contents true in there. Next, we have our on scroll function. This happens when the base UI determines a scroll event has happened. This will be called we've assigned it up here as the event, as part of the scroll event. So we get the mouse. Now this should probably be a cursor. So let's change this to cursor. Oh no, we're going to use the scroll wheel on here, so we can come back to the cursor stuff later. So we get the mouse. We determine if we've scrolled the mouse wheel. If we have not, we're going to check. We're going to check the. I already did it. We're going to check the cursor to see if we've kind of have our finger down and we're scrolling it manually. Otherwise, we're just going to use that scroll we got from the mouse wheel. We're going to check if we're scrolling in both directions or a single direction, and then we're going to do the scrolling and set the is scrolling boolean to true. Next, we have the panel on down. This is for when we click down on this panel. This will initiate that manual scrolling stuff. We do want to go through the children, all of the children, and that's what this target is. We're basically going to go until there are no more, or we're going to go to every parent. We're going to go from the child up, 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 up until we find the topmost parent, and then we're going to deal with the scrolling stuff on that. So we're going to say we're dragging on that panel that we found. The next one is going to be the should add scroll events, and this is going to be used to hold on a second. Okay, sorry, my nose is bothering me. This will be used to tell us whether we should add the scroll events in, basically based on the size. So if we have any sort of scrolling available because the content is larger than the size of itself, then we need to enable it. So that's what that's for. The next one is a helper function for disabling scrolling events. This will go through all of the children and remove the scroll events on them, which is required when we take a hold of the parent scroll. If we're scrolling on a parent, all the children's scrolls need to stop, and we need to focus on the thing that's being scrolled. Likewise, if we're scrolling just on a child, similar kind of thing, the child's children, all that sort of stuff. Then whenever we're done with that, we want to be able to try and enable those scroll events. So we're going to go through and add the scroll events to anything that's not a panel. So I should say is panel here, just to make that clear, is panel. So next we come to our update function. It's pretty straightforward. Call the base UI update and then do our scrolling stuff based on if we are not frozen and not allowed to scroll. We have a structure to help us for building out the child elements. This is called row builder, so we can build along the x-axis the child elements if they are allowed to build along the x-axis, because they'll try to flow. They'll flow top to bottom if they fill the width, but if you have two child elements that are say half width, it'll put them side by side on that same row. So next we have the add element. This will add a element to this. Basically, we have a row, and we're going to be setting up this row to determine if we can add more elements, if we're not allowed to because we've exceeded the row's width. That's what the Boolean return is for. So it tries to add this child to this row, and if it can, it'll add it. If it can't, it'll return false. Next, we have some helper functions to determine the width of the row and the height of the row. And then we have our set elements function, which is where this whole row builder goes in and writes out the child elements that are in the row. So it essentially goes through and deals with the positioning, absolute, relative, that sort of stuff, similar to CSS. Like I said, I'm making this UI so that we can make it either manual to create the UI. We can use a special specification like a YAML file or a structure inside of Go, or we can use plain old CSS and HTML to build out our UI. So this is going to go through and actually build out that row. It's going to go through each element and place it within the parent. So next is the big chunky function. This is a big function. This function is on rebuild. This is when the screen size changes, the panel size changes, there's many ways that the rebuild is called. If it gets dirty and you have to clean it, it'll get rebuilt. So on rebuild, this happens as an event. It's triggered. It's going to disable all the events. It's going to essentially say if there's no children, I don't have anything to do. Just draw me normally, essentially. Otherwise, it's going to go and figure out the row offset. It's going to create the row builders. It's going to figure out the whole area that it contains, so that it can place the children in it. It's going to go through each of the children. It's going to set up their sizes, their adjustments, and set them up for being placed within this panel. For example, if we have a panel, we don't want our children floating around inside of it. We can, but we don't want it in most cases. So let's say there's a scroll panel. We've got to make it so that they stack on top of each other and they're not just arbitrarily floating around. So that's what's getting a lot of that's being set up there. Then we're going to all the rows have been built previously also inside of that. And then we're going to say if we're fitting the content, we do a bunch of math and stuff on the children to size it appropriately. And then lastly, we go through and we see max scroll. We set up how much scrolling we have on this panel based on the children and the rows and all that sort of stuff. So all this stuff is just placing the kids within the panel into rows. Now we can go to adjust kids on rebuild. This is a function you saw called up inside of this, adjust kids on rebuild. It's going to take that child element and it's going to set up the bounds that they are contained within, and kind of just figure out their placement based on the parent. It's just setting up the scissor as well. That's important. So when we're scrolling and a child element goes outside of the panel, either the top or bottom, we want to do that scissor where we cut off so it looks like it's contained within that panel. So this is the primary focus of that. Of course, you can't have children without adding children. Very straightforward. We're just setting the entity's parent to this panel's parent entity. Updating the layout, setting the group so that the child has the same group as the parent. So if the parent has a group, I should say, it tells the child that it has to be in the same group as the parent. And then we're going to try to set up the scroll events for this panel. Insert child, same thing, except we want to stick the child in a specific position in there. So we have 5 elements and we want to insert it right in the middle. We want to be able to pass in an index and tell it to insert straight in there. Remove child, obviously, we want to be able to remove children from our list. Pretty straightforward. We have our child function, so we can pass in an ID and get that child out and see what it is, use it. We can set the scroll speed for our scrolling. We can recreate the drawing. So let's say that the drawing is no longer valid. We've changed the background. We've done a few things. We've given it a different shape or mesh or whatever. We want to be able to destroy the current drawing and essentially recreate. So you'll see that I do a little trick here with that cancel destroy. I say destroy the shader data, which flags it to do a few different things. We say is destroyed or whatever. So we're saying destroy the shader data. Then we're making a copy of the shader data because remember this is not a pointer. So this proxy is a copy. The proxy is set to be destroyed because of the destroy event. We assign the proxy as the new shader data, and then we need to tell it not to kill the proxy. So if we wanted to make this a little more readable, we'd say proxy dot cancel destroy, and then we would do shader data as proxy. So that makes it a little more readable, but does the same functionality. Next, we want to be able to remove the drawing like you're removing the background. So we're going to recreate the drawing, which is going to destroy it, but then we're going to clear out the drawing itself. So we're going to recreate the shader data, recreate drawing, recreate. I'll rename it once we're done. That's recreating the shader data. Next, we want to be able to set the color of the background. It uses that ensure background exists. If it doesn't exist, it creates it. And this just sets the color for that panel. We're going to set the scroll X so we can, outside of this code, set where our scroll is so we can scroll the panel essentially through code. We want to reset the scroll. Next is our ensure background exists function, which is going to say if the drawing is not valid, which means we don't have a background, we're going to set up the texture. Of course, this texture is an arbitrary one because we're saying ensure it exists. We don't know what texture it is because there wasn't one passed in. So we just want to create just a regular old square or something, just something visible. Sets up the shader, all the shader data, creates the drawing, and adds the drawing to the host. So next we want to be able to set the background. So we want to give it a texture and be able to set the background. We have to recreate the drawing for that because we can't guarantee the texture is going to be the same texture. Next, we have a few functions. We're going to be able to remove the background, determine if we're currently scrolling, freeze the panel, unfreeze the panel, and check if the panel is frozen. So those are mostly just helpers. And then we're going to do a set scroll direction because we may want to change how this panel scrolls at runtime, where it can only scroll against the horizontal or only scroll against the vertical, which we may determine based on the contents of the panel itself. And then we want to be able to tell which scroll direction we're in. So with all that, we have our panel. We're going to do some testing of the scrolling and stuff another time. For now, I just want to make sure that the thing works. So here inside of the main, we're going to get rid of test OIT, and we're going to do test panel, pass in the host. Very simple function. We'll do func test panel, get the host, create a texture for it, and this is just going to be not the Android one. This is going to be assets.squares, texture square there. We don't want nearest, we'll do linear, even though it's just a white square, it doesn't matter. P is going to be the panel is equal to UI new panel. We're going to pass in the host. We're going to pass in our anchor, which I want it to be in the center of the screen. So we'll test that UI.anchor center. And then pass in the texture. And then lastly, we're going to change the layout and scale this thing to 128 pixels. And we'll give that guy a run. And hopefully when it runs, we have a white square in the middle of our window. Okay, we don't have a white square in the middle of our window. So I had this running before. Let's try this again. I had RenderDoc already running. I was messing with some stuff. So let's take a capture of it and see what it thinks the transforms are on this guy. Mesh. Here's our input and our output. Oh, his GL position is 0, 0, 0. His frag color is fine. Border length, frag color. The scissor is correct. Frag text. So it's just this GL position that we're having some trouble with here. So let's go to. Oh, I bet you. Where do we create the drawing? So is this panel? No, panel. Oh no, we have the transform in there. So the transform is going in. So let's go over to our transform. It should be dirty, so I should hit this breakpoint whenever I first launch. So let's launch this guy. So it is dirty. I'm hitting that breakpoint. Now we're going to do update matrix. So let's step into update matrix. And what's our scale? Our scale is correct, 128, 128. What's our rotation? That's correct. What's our position? 64 on the X and fourth. That doesn't seem like it's centered. Okay, that's fine. Let's just come up, out. This is in the update model. This is inside of update data. Okay, so I think we should have hit that model before that, perhaps. Let's make sure our panel update is happening. Update. Panel update. Okay, we hit our panel update. Let's go down to let's go to our layout update. Okay, floating is correct. Hold on, let's see. So the scissor wasn't generated. So let's see what the scissor is. I think I saw it on the render doc. It was correct. So UI shader data scissor. Yeah, okay. Let's see what I missed. Okay, we already knew this, but as you can see, our model is all zeros, 0, 0, 0, 0. So we have an issue with our model assignment, which is going to be inside of our shader data base. So let's go to init, panel init, new shader database. Let's see what we got here. See if our model was set to an identity matrix as it should have been. Model. Okay, it's an identity matrix. So the problem comes when we want to multiply our matrices. So let's go to shader database and let's check out set model and update model. Oh, I guess I am not using set model right now. Okay, so do we have a transform? Yes, we do. Is it dirty? Yes. So let's step over. So our initial model is all zeros. So that shouldn't be the case, and that's because of we use this function, and I need to set our initial model to identity matrix. Okay. Oh, that's why. Cool. So fairly confident that's going to fix that problem because I have the set model which sets the initial model when we do that, and maybe I should use set model instead of this. That might be a better idea. But that's not centered. We'll deal with that in just a moment. Let's SDB, turn SDB, SDB.setModel identity, and then we don't have to do these. Okay, so let's run that, and while that runs, I'm going to go to the main and check out where we made our panel. Anchor center. Okay, cool. So that's still working. Now let's make sure this anchor center gets to where it needs to go. Here's our anchor. It's going into a knit. Here's our anchor. It's going into this initialize. Here's our anchor. We have anchor 2 top left in here, so let's get rid of that. So that should center our, there we go, now it's centered. So I'm going to try this other thing. If it's not working, then that's something to deal with later. But I'm going to try a stretch top. And I'm going to get rid of the scale because we're stretching now. I'm going to do stretch and then, is it dot stretch, set stretch. The left, we're going to go against the left side of the screen. The top, we're going to be at the top of the screen. The right, we're going to be on the far right of the screen. And the bottom is the height of this stretch because it's stretching against the top. So if I put 50 in here, it should basically span across the entire top of the window with a height of 50 pixels, which it is right here. So if we wanted to make it a little bit more obvious, I can offset it from the top by, I'd say 100. I have a feeling that looked a little bit smaller than 50 pixels. So yeah, the first one we saw, it was centered on the top with 50 pixels. So that's one of the things we need to fix when we come back to it. Because I bet if I do 50 there, that's going to 50 or 25. I think 25, it's going to make it hug against the top there, which we don't want. When we're stretching against the top, we want the very top to be stuck up there. So I think I have a boo-boo somewhere in my stretching code or my placement code that's not considering uh, the mesh. But let's go over to the panel first and let's make sure our mesh is the proper mesh. So it's a new mesh quad. Let's try new mesh quad, screen quad. See if that, I think it has to be a screen quad. So the bottom left is the bottom left corner. And let's try this now if I do 25. No, the screen quad tripped up the whole thing. So yeah, it was correct in being a mesh quad. That's going to bug me a little bit. Okay, I was just looking around, and it looks like when we do the, I must have ported something wrong when I was doing the layout, because these are clearly named for the midpoint. We want the midpoint X and Y for the stretches. But we're not doing anything with the midpoint. We're just passing it back as is. So I might take a look at the code and we'll come back to this as a bug so I don't wind up doing it here. Just because, like I said, I've battle tested layout code, and I think when I ported from C to Go and then from the last Go to this Go, I missed some variables or something. So if I wanted to fix this right now, I would just change this, let's see, X size. Yeah, stretch top is the X size here. This Y mid is returning the mid, but we're using it as if it was like the corner, so we'd have to actually move that. So that's what's going on here. We'd have to like subtract by the height divided by 2 or something like that. But I'm going to leave it there for now. It's basically working. Just the layout needs some adjusting here. Cool. And let me check while we're here. Let's say if I said bottom left, if I was to say dot offset or set offset to 0, 0, see what that looks like real quick. Let's see if I have to fix both the stretching anchors and the, oh, this one's not even showing up. So yeah, I got something goofy going on here. Let's try top left and see if we have a different result. Definitely got something goofy going on here with the anchoring. This bro doesn't even want to show up now. Make sure I didn't mess up any of the code I just did. Let's do anchor. Oh, I didn't set the size. It's like a pixel layout. That sets our scale to 128 and 128, and then we'll set our offset to the bottom left corner. So that looks about right. So if I moved it, let's say 10 pixels to the right and 10 pixels up from the bottom left corner, let's see what it's at. Yeah, okay, so the floating anchors seem fine. It's just I just have a bug with the stretching anchors. So I gotta see what I don't want to just hack in the division stuff. I want to make sure that I actually ported from the C code correctly all the way over here, so that just because I know that's battle tested, it has, you know, many people have used the application and test the application and works great. So I want to make sure I use the same code I had there because it's gone through its paces. I'll leave this here, and this is how I'll commit it. So, yep, look forward to fixing the layout probably in the next one. Thanks for watching. Okay, I actually took a minute to check out that layout thing because it bugged me. It actually has nothing to do with the layout. It's because the window height is 500 pixels. It's 500 pixels from the absolute top edge right here to the bottom. So our viewport is not 500 pixels. Technically, our viewport is 500 pixels, and it's going up here behind the title bar, essentially. So that's actually what the issue is and what we need to resolve. So I tested that by setting the bottom. I set it to stretch bottom with the height of 50 and 0 offset from the bottom, and it worked correctly here. So, and I did notice it's about the height. This is about 25 pixels, and it just turns out to do that. Uh, so, I mean, just to double verify, um, if I used a more interesting number like stretch top 150, if I did 25 there, then this would kind of prove that that's the issue. So as you can see, if I add now 50, which is definitely not half of 150, 75 is. So if I do that, it's going to be offset from the top C. So it's actually the window height that needs to be adjusted. So that is still going to be in a different video, but kind of wanted to clear that up before I created the task for it. Cool. See ya.